Let me get my share screen ready. All right, so today we are completing exercise 4.8, numbers 1 through 4 for your homework. Before we do that, I want to talk a little bit about interior and exterior angles. So far we really have only been talking about the interior angles here. And what we have known is that the interior angles, every triangle adds up to 180 degrees. So in something like a quadrilateral, or here a square, you have two triangles. So 180 plus 180 is going to give you a total of 360 degrees for your interior angles. Here again, we have 1, 2, 3 triangles inside of this pentagon. And so again, we have 180 3 times to give us 540. Yeah. And then here with our hexagon, again, we can create 4 triangles. Each triangle is going to equal 180 degrees. Again, I don't really have to write out 184 times. I can just say 180 times 4, but whatever. And so this one is going to equal 720 if you add up all of the interior angles for this polygon. So these are all polygons that we're talking about here. But let's go ahead and look at the other half of things. No, I'm going to do yellow. Okay, so here for our exterior angles, if I were to take this and extend it out here, here, and here, these 1, 2, 3 are my exterior angles for my triangle. And the sum of all, well, let me keep going. So this, I'm going to extend this line out, here, and here. And these are my 4, holy smokes, my 4 exterior angles. Again, here, if I extend out these lines like they continue forever, these are my 5 exterior angles. And here, these are my 6 exterior angles. Okay, now exterior angles are a little bit different from interior angles because the sum of your exterior angles always equals 360. Okay, so you can see that when I'm looking at this angle here, my first angle for this one, it's a little bit bigger than the first angle for my quadrilateral, and it's also a little bit bigger than the angle for my pentagon, and certainly bigger than the angle for my hexagon. Okay, so the sum of your exterior angles is always going to equal, sorry, I was just looking at something, always going to equal 360. Wow, my mind was really off base there. Okay, so now that we've gone over those basic principles, let's start doing some of your homework problems together, okay? You know what I should have done? I'm going to take a quick screenshot before we move on, because I totally remembered to do anything with it last time. All right, got it. Cool. Now I can erase in peace. All right, cool. So let's take a look at your homework problems. So let's try, I'm going to try one of each one of these together. So let's do 1A together, and then you will do B and C for homework. Okay, so 1A, it says find the sum of the interior angles for the following polygons. So this one is a hexagon. Hexa means 6. So if you were to draw something with 6 sides, I'm looking for interior angles. I want to see how many, actually, different color, how many interior triangles can I create? Well, I've created 1, 2, 3, and 4. But something that's important to know is that the number of interior triangles is always the total number minus 2. So you're going to have 4 interior triangles, or we can say 4 times 180. So 4 times 8 is 32, so 320 plus 400 is going to give me 720 for my total interior angles, for the sum of all of my interior angles. All right. So attempt this for B and C on your own. Now let's take a look at 2A. So here it says find the value of each interior angle of the following polygons. So 2A is an octagon. I hope you guys liked that video that I found for you guys on YouTube too. Octa means 8. Think octopus. An octopus has 8 legs, tentacles. So the value of each. Now, first of all, we want to know how many degrees total we're going to have. So that's going to be it's going to be 8 minus 2 equals 6. So if I were to draw an 8-sided figure, I would be able to complete 1, 2, 3, 4, 5, giving me 1, 2, 3, 4, 5, 6 interior triangles. So it's going to be 6 times 180, because each one of these triangles, the sum will be 180 for each one of them. And let me see. So 6 times 8 is 48. 480 plus 600 is 1080 degrees. Okay, but now what I'm looking for is we're assuming that this is with a regular polygon. Actually, all of these problems are assuming that we're using regular polygons. And let me use a triangle for an example in order to describe what I mean by that. So if I have a triangle like that, is that a regular triangle? No. If I have a triangle like this, is that a regular triangle? No. If I have a triangle, mind you, this is terrible drawing, but if I have a triangle like this, is that a regular triangle? Yes. Now, looking at these three, what is different about that triangle that makes it regular? It's because all sides, rattlesnakes, I need to stop doing that. All sides and all angles are equal to each other. So an equilateral triangle is regular. So here when I'm looking at an equilateral octagon, all of my sides are equal, and all of my angles are also equal. So I'm going to take this number, the total sum of all of my angles is 1080. So I'm going to take that and divide it by the number of angles that I have total. Octagon, I have 8 total angles. 1080 divided by 8. So I know 800 divided by 8 is going to give me 100. That leaves me 280. Why am I blanking? It's late at night. That's probably why I'm blanking. Okay, so 32 is 4, 24. Instead of 280, I'm going to do this. Brown, brown, brown. I really did this to myself. You shouldn't stay up late and try and do work late. Okay, so let's do it like this. I've got 280, but I've got 240 divided by 8. I know that's going to give me 30, which leaves me 40 left. And I know 40, I can't, it's too close to the button. 40 divided by 8 is 5. So each angle is going to be 135 degrees. Okay, so let me just stop for a second in case some of you all are like, what, help? Let me review the steps that I just did. So first, I took the number of sides and I subtracted 2 to get the number of triangles in the polygon. So for example here, 8 minus 2 equals 6. There are 6 triangles that fit in an octagon. Then multiply by 180 for total of interior angles. So here we did 6 triangles inside of our octagon times 180 equals 1080. Then from there, we divided the total sum of the interior angles by the number of angles. So that was here, 1080 divided by 8, okay? Which gave us 135 for the value of each interior angle. I'm gonna stop really quickly, take a quick screenshot. I swear, I'm gonna actually give these to you this time. I am really tired, guys. It's like 9:30 right now. I shouldn't be that tired. But so I don't have a car right now. I'm living that sad life. But there's also, well, it's not that sad when you have public transportation. But I don't have public transportation here. I'm like out in the middle of land. So I walked like 10 kilometers today to get a coffee and go to the grocery store. I'm tired. I know, boo-hoo. 3A. Find the size of each exterior angle for the regular polygons, just like we were talking about regular. So we know all angles and all sides are equal to each other. Pentagon. Penta means 5. This is not perfect, so it's not really regular, but that's fine. So again, if we're talking about exterior angles, it means I'm talking about these guys. Okay, so what's the size of each? So remember, the sum of all exterior angles is going to equal 360. I take that and I divide it by the number of sides. I know 300 divided by 5. My brain. I already did this one. Let me just look at my answer. I did this one. I did this one. 72 degrees. So again, let me take a second and let me just write out the directions. So 1, you divide 360 by the number of sides. Kind of easy. Well, it depends, but simple directions at least. Not a ton of steps. All right, so last one from our example, 4A. So the exterior, this one's going to require a little bit more work. The exterior angles of a regular polygon are given below. In each case, calculate the number of sides. Okay, so for 4A, the angle, the exterior angle is 20 degrees. So what we want to do here is, if I were to take this equation here and kind of create a formula that I can use, it's going to be 360 divided by, let's say, S for the number of sides, equals A for angles. So I'm going to create a little key down here. S means number of sides. A means exterior angle, okay, in degrees. So if I were to plug in values here, 20 here is going to be A. So I'm going to take this formula, I'm going to make it colorful, and I've got 360. I don't know how many sides, that's what I'm looking for, but I know it's going to equal 20. So what I'm going to do to solve here is I'm actually going to look back to an old trick that we learned, which is cross multiplication. Any integer has a 1 in the denominator. So now what I'm going to do is I am going to cross multiply. No, I don't want to use that color. So here, 360 times 1 equals 360. And then, well, no. It really doesn't matter. I could literally choose any color and it would be fine. And then S times 20 is going to give me 20S. Now, in order to isolate my S, I need to do the opposite to the 20, and that's divide it in order to get rid of it. The 20 cancels out on the right side of my equal sign, leaving me just S. And here, 36 divided by 2 is 18, and then the 0 and the 0 cancel out, okay? So there are 18 sides to this polygon that has exterior angles of 20 degrees each, okay? So I'm going to stop for a second and I'm just going to write out the directions of what I did. So step 1, I set up my equation like I did right here. Step 2, I cross multiplied. And then I divided both sides by the coefficient to isolate S. Okay, that's all for today. I'm going to take one last screenshot. No! And so please complete numbers 1 through 4 for homework tonight. I hope that was a helpful lesson. I'm sorry I'm so tired, but you know, that's just how it goes when you don't have a schedule you have to keep to. All right, see you guys soon. Bye.